Welcome, sir. Yes, sir. Yes, sir. Welcome, sir.
Sir, I have two accounts.
Okay. Let me add another account. Yes, got it. Got it. To the panelist. Yes, sir. Yes, sir. It is there. Now, sir, you will be able to share your screen. Yes, sir. Your screen is visible.
Good afternoon, sir.
Yeah, can you hear me? Good afternoon.
Good afternoon, sir. Yes, clearly audible, sir.
Yeah, thank you.
Yeah. Sir, shall we start?
Yeah, please.
Okay. So once again, I welcome all the participants after a lunch break. So we will be starting our session 2 of day 1 with the topic Advances in the File Load Testing, Challenges and Way Forward by Dr. Dasakamurthy. Dr. Dasakamurthy is presently working as professor in the Faculty of Civil Engineering at IIT Bombay. His current areas of research are foundations, retaining walls, vibration mitigation, instrumentation, and forensic geotechnical engineering. He has been actively involved in teaching and research at IIT Bombay. He has obtained research grants from several government and private organizations, and he has been serving as an expert consultant to many organizations. Presently, he is serving as a chairman of IGS Mumbai chapter and secretary TC 302 Forensic Geotechnical Engineering of International Society for Soil Mechanics and Geotechnical Engineering, ISSMGE. So with this, we welcome you, sir. So I request Murthy sir to engage the session. And once again, I request participants to keep their questions, and you can post your questions in the chat box or the QA end box, and we will take up those questions at the end of the sessions. Over to you, sir.
Yeah, thank you, Saraswati, for a brief introduction, and welcome all the participants for this FDP program on emerging trends in geotechnical engineering. So my voice is, I'm getting some echo. Let me check whether I need.
Yes, sir. Echo is there.
Yeah, just. Yeah, now you see, I think it is fine.
Yes,
Yes,
sir.
sir.
Now it is fine.
Yeah. So let me share some of my thoughts on file load testing today. I'm sure you must have enjoyed Dr. Basarkar's lecture in the forenoon session. So I'll be presenting to you some of the very basic concepts of file load testing and what are the challenges and what are the way forward So as part of this lecture. So if you have any questions, as mentioned by Saraswati, we can pick up those questions towards the end of the session. Now, let me move. So you see, every day is a learning experience, and let's see that today we learned something new in this FDP program. We all know that load tests are very common in geotechnical engineering, and load tests are conducted to verify design calculations and to measure the load carrying capacity of a system, whether the system may be a shallow foundation, a pile foundation system, maybe a retaining wall system, or anchors. And while conducting the load test, not only the maximum load what the system can carry, but we can also get settlement or deformation pattern of this system under any given load. Load tests are conducted as part of shallow foundation design. So very common for pile foundations. And I should say that when it comes to pile foundations, load tests are mandatory. And we'll discuss that part in today's presentation. And even retaining walls can also be load tested, like anchors, whether they are soil anchors or rock anchors, in order to understand how much load they can carry. At the edge of failure, we can conduct a load test. Now, this lecture is exclusively on pile load test. And then when it comes to pile load test, again, so why we conduct a load test or pile load test is to check the reliability of several solutions which we use for day-to-day calculations. We have analytical solutions, empirical solutions. We have many semi-empirical solutions. I should say the moment we say semi-empirical, maybe the solutions which take the SPDN value or cone penetration test results to find out the pile capacity. Now, whenever we use an equation, so as a concerned engineer can always have a number of questions in mind. The first question is, if I use an equation to find out what is the pile capacity, whether it is ultimate capacity or safe capacity of the pile, how confident am I in the value what I'm getting using these equations? And it is not very surprising that many of these equations will give a quite different values of the capacity. And that is the reason. So in order to understand, so what is the most reliable load which a pile can carry at the verge of failure, or which a pile can carry in a safe state. So means what is the safe load carrying capacity of the pile. Now these load tests are conducted very quick fashion. For example, if you see the life of a structure, maybe 30 years or 50 years or 100 years now. So it means that all these pile foundations, they are subjected to structural loads throughout the design period of the structure. However, by load testing, find out the pile capacity, we are only testing the piles in a very short time. So the maximum, if you look at the duration of load test, the duration of the load test is very small. Maximum maybe 4 days or 5 days. And compare the duration of the load test with the life of the structure. So that is the reason. Whatever settlements we are getting when we are load testing the pile foundations is only a short-term settlement. If you apply the same load for a long period of time, it is certain that we get significantly higher settlement values. That is the reason one should be very careful when we evaluate what is the ultimate capacity of the pile and safe capacity of the pile. And probably this is one of the reasons why we always use a factor of safety while designing our foundation systems. Factor of safety guarantees that even though we are estimating the pile capacities based on short-term loading, still the structures will be safe enough because we'll be using a significant factor of safety on the design part. Now the load test can also be conducted if you want to separate shaft and end bearing resistance. Now if I show you that if this is the pile foundation and this is the ground surface, now on the pile you have a superstructure constructed. Now if you see, once this pile is subjected to a load from superstructure, now soil offers resistance. Now if you see here, soil offers resistance all around its periphery. Not only that, even soil offers resistance at the base of the pile foundation. This is called end bearing resistance, and this part is called shaft resistance. Now if I say that the pile capacity, a given pile capacity for a pile is, say, so 1000 kilonewton, so it is a low value. So if I want to understand out of this 1000 ton, how much is carried by the shaft of the pile and how much is carried by the end bearing, in order to understand that, so we can do a pile load test and separate the total load what is carried by a pile into shaft resistance and end bearing. Similarly, load test can also be conducted to understand the quality of pile construction. So many times piles may be subjected to some kind of erratic behavior during the construction process. Now, what exactly happens here? So you may be interested, so as a designer, to construct 1 meter diameter pile and 20 meter length of the pile. As a designer, so if you ask the contractor to construct 1 meter diameter pile and 20 meter length of the pile, in reality, once you remove the pile after it is completely set or cured, is not very surprising that the pile diameter may not be 1 meter throughout. Maybe if you look at this, maybe of this nature you may get. Okay, so this is how in reality you may see the diameter of the pile. Similarly, the length of the pile also, so you assume that the pile simply you make a bore at the ground and then put your reinforcement cage and then so you put concrete. You as a designer, you assume that your pile is resting on a soil, but in reality, while making the bore, if the pile bore is not cleaned properly, whatever length of the pile you are saying 20 meter may not be 20 meters, sometimes maybe more than 20 meter, because please remember, unlike the structural components which you see above the ground, it is very, very difficult to visualize or to inspect any construction below the ground surface. Now, very simple case where if I say to you that you construct a column of, say, 500 millimeter diameter and say 4 meter height. If I ask you, if you are a contractor, if I ask you that construct a column of 500 millimeter diameter and 4 meter length above the ground column, this is a column. Now, because it is above the ground, you have all the control. You can always create your formwork, make your formwork in such a way that the diameter of the inside diameter, the hollow portion is 500 millimeter, and you have very well control on the height of the measure. But imagine that if the same case, if I talk about, okay, now same thing, we go for 500 millimeter more than that diameter of the pile and 4 meter or 10 meter below the ground, because you only can make a hole below the ground. I'm talking about board piles. And so while making a bore inside the ground, there are many things come into picture. One thing is making a borehole. It is not the end. Basically, what we need to do is when you are having your auger, okay, which cuts the material. So you may remove the auger after it reaches 4 meter or maybe 10 meter below. But before you put your reinforcement cage and after you remove the auger, there is a possibility that your sides of the board may be collapsed. These are some of the issues. That is the reason the field behavior of the pile foundations is very different from what we understand at the design stage. That is the reason pile load tests are made mandatory in the geotechnical engineering. Not only that, the other reason why pile load tests are made mandatory, because piles are normally constructed. The loads of the structure where the loads are very high. Now, unlike in the shallow foundation system, the loads are very high. You may not be in a position to design a shallow foundation system. However, when your loads carried by the columns are very high, and where the shallow foundations are not suitable to support the column loads, we go for pile loads. Okay, when you have very high loads, okay, so which you are planning to support. So in that case, if you see the structural system, maybe if you see maybe a 5-story building or 10-story building, okay, so which may require the piles, not a 1 or 2-story building in general sense. Now the as the number of stories of the building so increases, there are many issues come into picture. Even your what I should say, the allowable settlements in the case of piles is so low compared to allowable settlements in the case of shallow foundations. Now, if you look at the load tests, so load tests are of two types depending on the load application, how you are applying the load on the pile. Now, in most of the cases, you see a maintained load test, but there is a test called constant rate of penetration test, which is a quick test basically. Can also be conducted to obtain the load carrying capacity of the pile. So now, what is maintained load? Maintained load means basically what we do is we apply the load in a stress controlled manner. For example, let us consider that I want to apply a load of say 1000 ton. Since the pile has is required to be load tested up to 1000 ton. Now, in the maintained load test, what we do is we divide this maximum load to be applied in increments in number of stages. Let us say each stage may be of say 100 ton. Now, what you do in the maintained load test, you apply 100 ton load and maintain it for certain duration. Now, we'll see that part also. Now, let us say that each load should be applied for 1 hour. During this 1 hour period, so you need to see that the load experienced by the pile is 100 ton. Now, if I show you here, so this is how it looks like. Now 100 ton you apply. So now this is the load, and this is time. Now, what we do here is, okay, you apply 100 ton load, then maintain this, nothing but so load should be constant. And then after, so let us say this is 1 hour. Now, after that, you apply the second load increment, then again maintain, again third increment, then again maintain. Like this is what is the load maintained load test. Okay. So on the other hand, if you see constant rate of penetration, so wherein what we do is the load is not maintained constant. Instead, the time versus settlement. the settlement, for example, if you see here, this is like this. Now, wherein we say that let us say 1 millimeter per minute means load is applied in such a way that the settlement of the pile is 1 millimeter per minute or maybe 5 millimeter per minute. Okay, so in this fashion, load is applied. So means basically load is not kept constant, but the settlement, the rate of settlement, 1 millimeter per minute, that is constant. That is the reason. So this has this constant slope and the settlement time plot. So code approves both these methods of loading when we are doing a pile load test. Now also when we're talking about load test, please remember, so reference to direction of loading. So this is the pile. Let us consider this is the pile. Now this is the axis of the pile. With reference to axis, how the load is applied, whether so it is vertical and symmetric about the axis of the pile. This is what we call as a vertical load test. And then in the vertical load test, maybe you are applying a compressive load. In some cases, for example, if you talk about a transmission line towers, transmission line tower structures, what happens here? So the just a minute. Sorry. In the case of transmission line tower foundations, now because you need to provide a foundation system here for all these legs of the tower. Now in this case, what happens predominantly, the loads on the foundations, if you talk about loads on the foundations are tension in nature. In that case, what we do, so we go for a pile foundation, we make a pile foundation, but then not the compressive load, what we do is we try to understand at what pull, okay, at what tensile load the pile will be lifted up. Okay. Now this is basically a vertical load test we conduct, and in the case of lateral load test, now for example, if you talk about a bridge deck, here. So now this is a bridge. Now the bridge deck is supported by pile foundations. Now if you look at the pile foundation here, now this may be the pier of the bridge. Now below that they were pile. Now if you see here, so significant horizontal load is also acted on the pile foundation apart from the vertical load. Now in order to understand the lateral load capacity of the pile, we conduct this particular lateral load test. So now we conduct a pile load test. Please remember two things are essential. So one thing is what is the load we are applying, load on the pile. The second one is what is the settlement of the pile in the case of compressive loads or vertical loads, or in the case of lateral load, what is the deformation of the pile when you are conducting lateral load test. Now, how much load you are applying on pile in each stage? For example, if I consider again maintain load test, so how do you measure? So how much load you are applying on the pile? Okay. How do you measure the load? That is one part. Second part is how do you measure the settlement and deformation? Now, if you see, traditionally, we use hydraulic jars to conduct a load test. What we do, we put a hydraulic jug on the pile to be tested, and this hydraulic jug is pressurized from a pressure pump located on the ground surface, and through the pressure gauges, we measure what is the load applied on the pile. But please remember here, the measurement of load using the pressure gauges is not very reliable. The second thing, so there is a possibility that load, whatever load we are applying on the pile, okay, may not be accurate and nothing but, so we don't know whether we are really applying or really maintaining the load in each increment constant or not. Of course, what is the solutions? We'll see. There is a load cell. If you can place a load cell above the hydraulic jar, this load cell, being an electronic system, can give you a continuous and accurate, reliable measurements of load which are induced on the, which are applied on the pile. Of course, even strain gauges are also used to find out if you are loading a pile here. This is the pile, you are loading a pile. So now let us consider here. Now, in one instance, you applied 100-ton load. Now, when you are applying 100-ton load on the pile head, and you want to understand, if you are interested to understand, so this is the ground surface. Now, maybe 1 meter below the ground surface. If you want to understand what is the load transferred to the pile section at 1 meter below the ground, okay, then what you do is you can always put strain gauges here, and through strain gauges we can always obtain what is the load which is transferred to any depth below the pile head. You are applying a pile head load. As I mentioned here, not only the load, even under the load, we need to, when we are applying 100-ton load on the in the first stage, now 100-ton load is applied. Now I want to understand, so what is the settlement of the pile head? Now under 100-ton load, what is the settlement of the pile? In order to understand this, what we do is, conventionally we put a dial gauge here. We put dial gauges here on the pile head. But what happens when we are putting dial gauges? There is a possibility of human errors in that while recording. Because please remember, as I mentioned, the load test may extend or may sometimes to 5 days. Okay. So in that case, what happens? We cannot really assume that whatever readings are recorded by the crew there during the load testing, they are fully perfect. We cannot assume that, because see what happens, day and night you need to take the readings continuously, and while recording there may be some kind of human errors coming in the picture. Now, not only that, continuous recording is not possible. What happens here? So just imagine that you ask the operator to take settlement of pile readings, a settlement reading a pile every 1 minute. Now it is very, very difficult for him to do that. So, and also what happens because of these things, most of the times the data what we get may not be completely reliable. Of course, now technology is available in the market, and we can always use some digital or electronic devices which can give you the settlement of the pile head continuously by remote logging. Even you did not go there so near to the pile, and it gives accurate and continuous record, and it eliminates all the human errors involved. Of course, people use even total stations also to understand whether the pile is really moving under a given load, and if it is moving, what is the movement of the pile, vertical movement or lateral movement of the pile, can be obtained by total station also. Now, based on the how load is imposed on the pile with respect to time. So see here what happens. Again, coming back to the life of a pile foundation. Now this is a pile, and this is supporting a column here, column load. Now if you see, unless there is some kind of a dynamic events happen, like earthquakes, which are very, very short duration events. Now otherwise, if you see, columns are subjected to, so mostly it is static event. Okay, now what we require here in the design, I want to understand, for example, let a very simple case, I'll tell you. Now let us consider that my file or my column load, let us consider a column load. Column load is, say it is 290 ton. Column, a compressor load, a column is imposing on the foundation. So we want basically to design a foundation system for a column which is carrying 290 ton load. Now the question here is, in order to design a suitable pile foundation here, now my foundation should have a capacity more than, if I say that maybe 3. If I say 3 as a factor of safety, so approximately my capacity of the pile should be 570 tons. Now, how do I know whether I can always design, okay, now I design, let us consider that I designed the pile. Let us consider that pile is, say, 750 millimeter diameter pile. And length of the pile, let us consider it is, say, 15 meter into the ground. Now I designed the pile. So based on the calculations, what I have in the course of practice, I designed the pile, but I want to make sure that this pile should have a capacity of at least 570. For that, what I do is I can construct the pile the way the real piles are constructed at the site, at that particular site. And now I need to load test. When I load test, now load test can be what is a static load test. Now, once again, let us consider. So in the static load test, I can maintain load test. Now what I do is I need to check whether the pile can carry 570 and at least. Now what I do, 570 is the maximum load I need to apply on the pile. And this 570, so I'm dividing them into, say, increments. Now let us say each increment is 50 ton. Now first increment of load I put on the pile and measure what is the settlement. After some time I increase to 100 ton. Then again, once again, settlements are monitored continuously. Then say 150 ton like this, loads are applied on the pile. But then what happens here, the when you are talking about 570 ton or so, maybe it may not be much, very high. But let us consider that if I have a pile which needs to be tested not for 570 but 5,700 tons. Of course, the diameter of the pile nowadays, even you can see diameter of pile as high as 3 meter. 3 meter diameter piles can carry huge loads. Okay, so of course length is also very important. But then what happens? It is very time consuming if you want to conduct a static load. We'll see what are the various difficulties normally we encounter while conducting the static load test. In that case, what we can also do is we can go for dynamic load test. So dynamic load test, basically they are very quick tests, and whatever information we are getting from static test, we can also get from dynamic test. Okay, so in the dynamic test, basically what happens, we don't apply the loads on the pile head. Instead, we give hammer blows on the pile. So there is a hammer blows, a dynamic event. We give a heavier hammer hits the pile, okay, repeatedly, and then we continuously monitor the force which is generated in the pile, which is given to the pile, and also what is the displacement of the pile from the measurements, dynamic measurements, and we can always get a conclusion whether the pile has sufficient capacity or not. A very quick test compared to the static test. Now, again, when we want to conduct a static pile load test, so what I see ultimately two things. One is you need to apply a load. A load should be applied on the pile, and then under the loads, pile settlement should be monitored. Load should be applied and settlement should be monitored. Now, let us consider that if you have a system, for example, on the ground, if you have a ground, and if I say that I put a load of, let us say, 10 kg, Or maybe let us consider that I have a pile here. I have a pile here. Now what I ask you is you put a 10 kg on the pile. Now what you can do is you can simply carry this 10 kg weight. Okay. So then simply put it on the pile head. Now if I say, okay, now you load the pile with 100 kg, maybe you may bring 2 bags of sand, okay, and put it on the pile head. Now if I ask not 100 kg, now you put 1000 kg. Or if I put not 1000 kg, you put 10,000 kg on the pile. And what happens here, it is very, very difficult to load directly on the pile if the load is very, very high. Now, the ideal load test where what you do is whatever load is required, you simply put on the pile head. That is the ideal test, but ideal test is not suitable, especially when the loads are very, very heavy. Now, when loads are very, very heavy, what we do is we use a reaction loading system. We use a reaction loading system. So reaction loading systems can be in the form of template, in the form of reaction piles or ground anchor. So how this looks like, maybe I'll show you a photograph. Okay, now let us consider. So now what happens here in the reaction system? So now let us consider that, okay, my pile is, this is a pile to be load tested. What I do is, okay, this is a ground surface. Now I create a platform. This is what a reaction system. And this platform is loaded with, say, sandbags. And between the platform and the pile, I put a hydraulic jack. And whatever gap is there, so I fill with some kind of dummy plates, rigid dummy plates. What we do is we pressurize this hydraulic jack from the ground using a hydraulic pump. Now, to the hydraulic pump, there attached is a pressure gauge. Now, depending on whatever load you want to give to piles, you see the pressure gauge and continuously operate the hydraulic pump handle. And then now what happens here? So the oil will be pumped when you are operating the hand pump. And now, so the hydraulic jack is under pressure. Now, this platform, now what happens? Load is applied in both direction, one upward direction as well as in the downward direction. Upward direction, this reaction is quite high. For example, if you say that I want to load test the pile to maximum of 750 ton, now the weight of the reaction system should be at least 1.25 times 750 ton. Now, if you look at the weight of the reactions, so the weight is quite high. Now, when you are putting a load on the hydraulic jack, now hydraulic jack cannot move the reaction system upward. Instead, what happens here, because the load is also applied on the pile, now pile starts moving. This is a cantilever system where a heavy platform comprised of maybe some bags of material, sand, or maybe some locally available material, or maybe some steel beams, a platform made of heavy steel beams. This is a cantilever reaction system. In the reaction piles, what we do is we make a platform similar to what we did earlier. This is pile to be tested. Now this is again a frame, a rigid frame. Now this rigid frame is supported by piles. This rigid beam is supported by piles here, a group of piles. Now they are properly connected to the frame here. Now again, once again, so between the frame and the pile, you put a hydraulic jack, and then once again you start applying pressure. So now what happens here again? The capacity of the reaction piles is quite high. Now the pile now starts moving down. Similarly, ground anchors similar to reaction piles. Now in this particular test, what exactly happens here is once you put a hydraulic jack on the pile head and starts loading it, pile can only move with the vertical direction, vertical downward direction. It can only either pile can move or pile will not move. The load is very, very small. But there is one more type of testing which is coming up these days. It's called bidirectional load test, where what we do is we don't create any external reaction. Instead, let us consider this is the ground and this is the pile to be tested. Now we don't do any reaction. We don't give any external reaction. Instead, now jack assembly is placed at some depth within the pile system itself, and this jack system is again pressurized from the ground. In this case, what happens when you are operating the hand pump of the hydraulic jack? Now hydraulic jack is pressurized. Now it expands. When it expands, load is applied on the top portion of the pile as well as bottom portion. We see top portion of the pile moves upward direction and bottom portion of the pile moves downward direction. This is what we call as bidirectional load test. Okay, this is used for axial static compression capacity. Okay, in the dynamic load test, as I mentioned here, we apply dynamic load on the pile top, and we continue. What we do is we this is the pile to be tested. So for its capacity, static capacity, we what we say we apply the dynamic loading. So heavy hammer is allowed to hit the pile top continuously, and then what we do, we provide some kind of instrumentation on the pile, like accelerometers, and then strain gauges are attached to the pile section very close to the pile top, and through these measurements we can always get what is the load applied on the pile and then what is the displacement of the pile. Again, as I mentioned, dynamic load tests are very, very quick to conduct compared to the static load tests. Of course, they have their own limitations, which we will see in today's presentation. Now, what I say is the reaction loading system as a cantilever system. This is, you can see here, this is a heavy platform, dead weight. Okay. Now between the pile, this is pile to be tested, and this is a hydraulic jack. Okay. And then what we do is this dead load, and against the dead load, the hydraulic jack is pressurized and load on the pile is increased. Now, in this case, there is no dead weight system, but you can see here. So these are kind of anchor piles. Okay. They provide reaction, and again, same thing we do here. Now, this is a cell, as I mentioned, bidirectional load testing. What we do is we provide these kind of cells at some depth close to the bottom portion of the pile. Either a single cell or multiple cells are provided here along the cross section of the pile, and then we pressurize them. Same whatever we are doing here, we pressurize them. This portion moves up and this portion moves down, and we can always get what is the capacity of the pile from this also. A cantilever system, heavy blocks or maybe bags are placed, and against these reaction systems, the hydraulic jack is pressurized. Okay. Again, whenever we do that, please remember, so there is a certain distance we need to maintain between the pile and the nearest support of the cantilever system. Otherwise, this support system may interfere with the behavior of the pile, and your load settlement response will be different. Now, various things you can see here. So this is the hydraulic jack. Okay, and these are the dial gauges to measure the settlement. A load cell independently measuring the load, and these are the some kind of a dummy members, rigid members to connect the hydraulic jack and load cell with the rest of the reaction system. For the reaction piles, you can see here. So same thing, everything same, but only thing is instead of making a rigid platform or a heavy platform on the ground, what we have seen in the previous figure, Here what we do, we take the reaction from the reaction files. Okay, this is how you can see here. So the 7,500 ton reaction loading, 7,500 tons. So just imagine how heavier is this, and for testing 1.8 millimeter, 1.8 meter diameter bore pile. Okay, so the various pictures field regarding the load test, you can clearly see here. So the pile to be tested is shown here, and that you can see hydraulic jack is placed. And this is a heavy platform, you can clearly see here. So this is a platform. If you want more and more loads to be tested, then this platform should be more heavier. So what you can clearly see. Now, similarly, if you want not only a single piles, if you want a multiple piles to be tested, for example, here, are the H piles. You can see these are the steel piles of H cross section. Now these are a driven pile, and after they are driven, to understand their load carrying capacity, again a load test you can see here using a control system. So you can always do a load test. Various phases of the load test can be seen here. You can see here, so here the pile settlements are continuously monitored. Where dial gauges are placed here and they are continuously monitored. And this is the reaction system, and these loads, of course, and the deformations can be recorded. Okay, so here these are the kind of pictures you can see. So this is the kind of a control system so heavy, which is built to act as a reaction. Okay, and what you can also see the existing buildings, you can clearly see here on the very close in the close vicinity of the pile load testing site. This is how the control system looks like, and you can see here pressure pump. This is a pressure pump, and you can see so the cartridge is the reaction system in cartridge is under construction. I can see not only during the daytime, so you are required continuous monitoring, and it so happens that you need to also take the reading during the midnight. Okay, so that is what is shown here, and you can see here is the pressure gauge. This is the only thing which the operator can see. Operators who cannot see what is how much load is acting on the pile. Instead, indirectly, he reads the pressure gauge reading and understands if at all, for example, if at all 100-ton load is required to be applied on the pile head, now he calculates what is the corresponding pressure in the pressure gauge, and that much pressure is given by the operator while looking at the pressure gauge. Various codes of practice we have on the pile load testing now, IS 2911 Part 4. So we use here in India, and we have similar codes of practice from ASTM worldwide. So they are used, and even for bidirectional we have code of practice. Now, a pile load test you can see here. This is another pile load test where you can see this is a ground anchor. These are the anchors. This is not a very heavy reaction platform, but using Kentlet, but it is using the reaction using the anchors. These are the anchors. You can see here. So anchors are there, and all four sides. 1, 2 here anchors you can see. Here anchors are there, and also on the other side anchors are there. Now you can see you can't see here the pile head, but on the pile head a plate is normally placed. On the plate hydraulic jacks are placed. Hydraulic jacks maybe a single hydraulic jack or multiple hydraulic jacks can be provided. And you can also see here these are the dial gauges here, so which measure so the settlement of the pile during the load testing. Now, similar load testing. So, from one of the metro projects in Mumbai, you can see how extensive is the ground anchors. You can see ground anchors here, the ground anchor like this. Ground anchors are used as a reaction system. And again, you can see here, more than two hydraulic jugs are there at the side, which are placed on the pile is tested. Now, this is a close look of the pressure gauge, what I told you. So, and also the hydraulic jugs plate, which is placed on the pile, and this is basically called a datum bar or reference beam, to which dial gauges are connected to measure the settlement of the pile. Now, you can see the connections to the hydraulic jug, the hose, hydraulic hose, which is connected to the hydraulic pump. You can see here, this is another close look at the various elements of the load test. Now, based on the instance, when a load test is conducted, again, the pile load test is divided into initial load test, which is also called like preliminary load test, or routine test, called as working load test. Now, initial load test is before designs are frozen. Initial load test is conducted just to understand whether the whatever capacity we obtain from the analytical or empirical or semi-empirical equations, whether they are really valid for the pile at the site. Initial load test is conducted. But once initial load test is conducted, and if we say that, okay, this is successful, what happens? Either the same designs or modified designs are made, and based on that, all the piles at the site are constructed. Now, when all the piles at the site are constructed, again, just before the superstructure is constructed, routine load test is conducted, or a working load test is conducted on some of these piles. Okay. Again, just to verify that whether there are any issues in the pile capacities from one location to other location. So just verify that routine load tests are also conducted. But remember one thing, that initial load test, whenever we conduct on a pile, not part of foundation system. Is this pile on which the initial load test is conducted is not part of the foundation system, but the routine load tests are conducted on piles which are part of the foundation system. So, what is its significance? Now, initial load test, because it is not part of the foundation system, they can be tested till failure. But when it comes to working piles or routine tests are conducted on working piles or piles of a foundation system. That is the reason the maximum load to be applied on routine pile should not be more than 1.5 times the design load on the pile. But here, this can be 2.5 times the design load, or even till failure, because even if this pile fails, there will not be any issue, because that pile is not used to form the foundation system. Now, coming to initial test, if you see here, so there are many objectives, because as I mentioned, initial test is before the piles are constructed, okay, just to verify the designs. Now, from this, we can find out the ultimate load capacity and safe capacity as well. And we can develop some kind of a guidelines, okay, for acceptability of the routine test. And like that, so there are many other objectives for this initial test. Now, there is again a number of tests to be carried out. Code specify that the number of piles in a project is less than 1,000. A minimum of 2 initial load tests should be conducted. On the other hand, if you see routine tests are conducted after all the piles are constructed at the site, and again to determine what is the safe load on the pile. And then again, so the working loads, okay, to limit extent of safety, or maybe in terms of settlement kind of thing, if you want to verify, so randomly we select few piles and load test. And if we have found that any unusual performance, or if you want to check any unusual performance of the piles, that can also be verified by conducting routine tests. And again, you can see a number of load tests. Routine piles or working piles is 0.5% plot number of piles at the site, subject to minimum of 1 test. Okay. Now, let's see here. Number of piles should be load tested. How many piles should be load tested? So we have seen earlier, but please remember, so number of piles to be load tested depends on the risk level. You cannot say that this number is same for all the projects here. It is not same. Please remember here. Depending on the ground conditions, okay, complex or unknown ground conditions, then risk is high. Okay, and no previous pile test data is available, or you are using a new technique of piling, okay, which has limited experience. In that case, what we need to do is risk level is high. So in that case, we need to have the, one preliminary test, have one initial test for every 250 piles and one working pile for every 100 piles. Now, on the other hand, if you see consistent ground conditions, you know the ground conditions very well. You have a lot of pile test data available from the nearby sites, and you have a lot of experience in the piling in similar grounds. Then you can see here the risk is very, very low. Though this handbook says that pile load test is not essential, but Indian codes clearly say that pile load tests are essential at both stages, at initial level as well as at the level after construction of all the piles. Basically, initial pile load test and routine pile load tests are mandatory as per our codes of practice. Now, as I mentioned, so vertical load, most of the times piles are load tested to understand the vertical compression capacity. In some cases, you may also require to see what is the tensile capacity or pull load capacity as well as lateral load capacity. Now, when it comes to compression test, as I mentioned, using a template, so it is a very, very heavy platform. And then when we are making a template system, we need to make sure that the support of the template, nearest support of the template should be at least 2 meters away from the edge of the nearest edge of the test pile. Okay. So similarly, when you are using reaction piles or rock anchors, at least again you can see spacing between the pile, edge of the pile and the anchor should be minimum of 2 meters or 3 times the pile diameter. That should be measured. And we've seen that when we are conducting a static load test, we noted that a load can be applied in such a way that it is a maintained load test, wherein it is a stress control test, a constant rate of penetration. So what we call a CRP, constant rate of penetration test, it is displacement load test. And we also seen so how a bidirectional load test can be conducted. We'll see more details about these in the coming slides. Now, when to conduct a pile load test? So after the pile is casted, now you can see here, so at least if it is a cast in place, then at least 7 days hold. Okay. So this is one. Or also it says that at least the strength of the concrete of the pile should be twice the design applied stress. Now, in the case of driven piles, without making any bores, so in the case of granular soils, we give a delay of 3 days after the piles are driven inside the ground. And in the case of clay soils, you leave for 4 weeks after installation. You leave for 4 weeks before we conduct pile load test on these piles. And as I mentioned here, so in the maintained load test, the reaction should be more than 25% above the maximum load we want to apply on the pile. If you want to apply a maximum load of 1000 ton on the pile, then the reaction system, the capacity of the reaction should be 25% more, nothing but it is 1250. And we apply the maintained load test, vertical downward incremental loads. That is what we do. Now, how the load is applied on the pile. Now let us consider, as I mentioned, so if you want to test the pile for 1000 ton, for example, let us consider a 2-meter diameter pile. Say 10-meter length of the pile. This is the pile, and you want to test whether the pile can sustain 1000 ton or not. How do you verify? Now, in that case, what the code says that the 1000 ton, if it is maximum load, then so the design load should be 400 ton. Now, 400 ton, if it is a design load multiplied by 2.5 is this is 2.5 is the factor of safety. Now, the total capacity which needs to be tested is 1000 ton. Now, what we need to do is this load 400 ton, which is a design load. This design load should be divided into 20%, nothing but, so 400 divided by 5 is nothing but 80 ton. Now, how the load should be applied? Load should be applied in increments of 80. Start with 80, 160, 240, 320, 400, 480, like this to come up to 1000. If it is exactly 1000 is not possible, even little above 1000 tons is also perfectly fine. So that is how the load test is conducted. When you are applying each increment, you wait for certain duration. We'll see what is the duration. So and during this 80 ton load, minimum of 1 hour you need to wait, and during this 1 hour duration, you need to continuously monitor what is the settlement of the pile. And please remember, in the case of initial load test, the load to be tested is 2.5 times the design load. But in the case of routine test, it is only 1.5 times the design load. Now 400 ton is the design load. Now you test up to 600 ton, because this pile on which routine test is conducted, part of the foundations. And then again, you can see here, so each stage of the loading, as I mentioned, so you need to apply 80 for the case what I showed you earlier, 80, 160, 240, like this. Now this 80 ton should be applied till the settlement of the pile is less than 0.2 millimeter per hour, or you wait till 2 hours, whichever is earlier, subject to a minimum of 1 hour. It means that minimum duration each load should be applied is 1 hour, and maximum is 2 hours. Minimum 1 hour if the settlement is going, settlement of the pile is less than 0.2 millimeter per hour. In that case, 1 hour. If it is more than 0.2 millimeter per hour, you just apply for 2 hours. After 2 hours, now from 80 ton, you increase to 160 ton. Again, this load should be applied for 1 hour or 2 hours, depending on the rate at which pile is moving down. Okay, like this you apply, and when you reach the test load, nothing but the final load, now the final load should be applied for 24 hours. Now for the initial pile load test, now if you look at the 80 ton, for example, if I consider 80 ton in each increment, in total you need to do up to from 80 to 1000 ton, you need to increase. Now here it is in 5 increments, you use 400 ton design load multiplied by 2.5, nothing but 5 into 2.5 is 12. So basically you get 13 increments. Total 13 increments you need to do for the initial load test. For the routine load test, where you are only increasing the load by 1.5 times the design load, There 5 into 1.5 is around 8 stages or 8 increments you apply. Now, when you are doing initial load test, 13 increment, 13 into 2, if I consider the settlements are quite high, is 26 hours. At the final load, you apply for 24 hours. That is how the load test. Now, if I see the total load is applied for 50 hours, and after that, you unload the pile. Now, initial load test, as I mentioned, so estimated safe load multiplied by 2.5 times, or you end the pile when the pile head settlement is more than 10% of the pile diameter. Nothing but if the pile diameter is 1 meter, and you notice that when a certain load is applied and you notice that the settlement is more than 100 millimeter, which is more than 10% of 1 meter diameter pile, now you stop the test there. And in the case of piles, the applied load should not be more than 1.5 times the working load. And in this case, you just stop the test if the maximum settlement of pile exceeds 12 millimeter for diameter of pile less than or equal to 600 millimeter, or you continue the test till 18 millimeter settlement or 2% of the pile diameter, whichever is less, for piles greater than 600. Now you can see either you reach 1.5 times the working load or you reach these conditions. You need to terminate the load test on that particular pile. Now, what are the concerns with reference to pile load test? Now, can we really conduct a proper maintained load test or conventional rate of test? Okay, so many times it is not done. Okay, now I'll tell you why I say so. Now, please remember in the maintained load test, what we're saying, each load should be applied. First increment, maintain, second increment, maintain, third increment, maintain. Now, what happens if you use the conventional hydraulic jack? If you use conventional hydraulic jack, what exactly happens? As the pile settles down, the pressure gauge reading drops. Okay. Now, not only that, see, another thing is when you apply a certain load on the pile, for example, let us say you applied, say, third load increment, now 3 into 80. Please remember, this is a hypothetical case I am talking about. Each increment, if I say 80 ton, now when I apply 240 ton, it's by looking at the pressure gauge reading. How do I know whether 240 ton is really applied on the pile or not? Because I don't have any measurement here unless some advanced tools are used. Now, at any instance of time during the load testing, so the applied load cannot be measured unless we have some electronic devices with us. Okay. Now, as I mentioned, so load cannot be maintained constant. Hydraulic jack, with the use of conventional hydraulic jack, once the pile starts moving into the ground, the pressure in the pressure gauge reduces. When pressure in the pressure gauge reduces, nothing but what happens here is you apply certain load and you want to maintain, but in reality what happened is the load is reduced. Now, once again you apply certain load, then again load is reduced. So it is not maintained constant. Now, you can see how much loading is applied at any instance of time. So you can see what it is done is the pressure gauge reading, whatever is there here, and the area of the ram also called piston of the hydraulic. This is hydraulic jack here. This is hydraulic jack. Now, when you apply a certain pressure, the hydraulic jack, there is a portion of the hydraulic jack which moves out is piston. Now, area of the piston multiplied by the pressure gauge reading, that gives the load on the pile at any instance of time. Now, this is how it is. Now, you can see here, this is the lever we operate, and this is the, when we operate this, there is a piston, this comes out. Now, the pressure in the pressure pump
multiplied by the piston area, that is the load we are giving it to the pile. But please remember here, there are always certain friction losses here. There are always a loss of friction. Because of the friction, there are losses in the loads. That is the reason. So if you simply multiply the piston area with the gauge reading, that may not be realistic value of load we are applying on the pile. Now you can see what is the solution. Solution is this. It is always advisable to go for an independent load cell, which is an electronic device which independently measures what is the load applied on the pile. Okay, that if those things are used, then so we know what is really applied, what is the load which is actually applied on the pile, rather than depending on the product of the pressure gauge reading and the piston area. Now, in many load tests, maybe those who are experienced with the load test, you may see that in many cases load cells are not used by the contractors. Now they have their own excuses. What they say is we never used, okay, and we never had a problem with the conventional hydraulic jack. And they may say that, see, this is not there in the tender document and it is too late now because our load testing is starting tomorrow. Or maybe he may say that my jack is always right. These kind of excuses always come. But by not using a load cell, we are not in a position to measure the actual load we are putting on the pile. Okay, so that is something we should remember. Now, here this is very, very important observation by Felinius. He says that by not using a load cell and completely depending on the pressure gauge reading to get the load applied on the pile, we are many times go wrong. Okay, so that is what he says, and it clearly shows that load cell is mandatory for getting a realistic picture of load applied on the pile at any point of time. Now you can see here, so an error as high as 30%, as high as 30% is arrived at by reading the load from the pressure gauge. So by reading the load from the pressure gauge, okay, so we may in some cases read more load on the pile and some cases less load on the pile. The order of, you can see here, 40 to 50 ton, which is very substantial. That is the reason it is always essential if we go for a load cell. If you go for a load cell, you provide a load cell on the hydraulic jack. This load cell measures accurately what is the load applied on the pile. One thing we noted that with the use of conventional hydraulic jacks, we cannot maintain the pressure constant. We cannot maintain the load constant. Now, then what is the solution for this? Is there any solution? Now, you may use some advanced jacks where they are fully automated, and as and when the load on the pile is reduced, immediately the additional oil is pumped into the system. That way, the load on the pile is always kept constant. However, these automated systems are very, very costly. Okay. And they are not readily available with us. That is the reason people are also not interested to use them. Now, presently, what people are doing is those who are familiar that okay, pressure or load may reduce as the pile is settling down. What they do is they continuously monitor the pressure gauge reading, and then what happens, as and when the pressure is dropping down, they once again pump the additional oil by operating the handle. But then imagine, so when you are conducting a load test for more than 2 days or 3 days, can you expect that the operator does this operation, which is essential, which should be done every now and then? Okay, it is very, very unlikely that the operator continuously monitor the pressure gauge reading throughout all these 2 days or 3 days or more than that. It's not possible. So instead of that, what they may do is they give, okay, for example, you ask 80 ton per 80 ton load you want. Then what happens? What the operator does is, okay, so he operate the handle of the pressure pump to see that the pressure is corresponding to 80 ton here. After that, what he will do is for 2 hours, he may not be interested to see what is happening in the pressure gauge. After 2 hours, he comes and he simply increases the load to 160 ton. Now, during the 80 ton and 160 ton, what exactly happens in these 2 hours is very, very important. Otherwise, what happens? As I showed you here, that now this is the load you applied, 80 ton load you applied here. Now, instead of maintaining constant, the pressure is reduced like this. And once again, you go for 160, then again, so load is reduced hardly in a few minutes. Then what happens when loads are reduced continuously in the pile will not settle any further. Now, when pile is not settling any further, you ultimately what happens? Now, if you maintain the load settlement curve may be like this. And if you don't maintain the load, now load settlement curve is like this. Load settlement curve is very flat. Now, flat load settlement curve gives an impression to the designer that, oh, yes, load is very, capacity of the pile is very, very high. In reality, that is not the case. Now, what is the solution? Now, way back in 1967 itself, Dinesh Mohan from CBRI, he understood that continuous attention of the crew, occasional pumping of the hydraulic jack is required. Don't have any load maintainer with our hydraulic jacks. Now, you say these are the realistic problems, and then what he says that he gave a solution. What he says, if you look at this, what we want is we want a maintained load. We want a load, for example, in this case, I want a load of 40 ton on the pile for, let us consider that, okay, I want for 60 minutes, I want to maintain. Okay, now anyway, I cannot suddenly increase 40 ton. There is a ramp, basically slowly the load increase, maybe in a few minutes, load reaches 40 ton. This is what we require. Now, for example, if you see here, so similarly, if load is 150 ton, so this is what we require. So this load is increased to 150. After that, we want to see that average load on the pile is 150 tons throughout the loading stage. But what happens here is the load, as I mentioned, load is always decreased. For example, if you see here, so if you give this much load, this load is decreased after a certain time. Now, he says that now in this particular case, now if you want 40 ton load to be applied on the pile, now don't give only 40, instead you may give something like 50 ton. And this 50 ton, after a certain time, it will reduce and reach a equilibrium state. Now, overall, if you see, if this area and this hatched area both are almost identical, then the average load on the pile is 40 ton. Similarly, here, if you want to apply 150 ton, now don't give 150 ton. Let us consider you may be giving say 180 ton, and this 180 ton. So with the time, it will reduce to say 160 or so. Okay, then what happens here is, as long as this area and this area both are one and the same, so your load can be considered equivalent to whatever load you wanted to apply, 150 ton here or 40 ton. Now he says that whether you maintain the load or you don't maintain the load, but you use method of equilibrium wherein you pump additional or you apply more load initially, both are giving the same kind of load settlement behavior. That is solution what he provided. Now, when we conduct a load test, okay, so ultimately what we require, we don't want what is the load applied on the pile and what is the corresponding settlement. This is not required. What is required is what is the capacity of the pile. What is the ultimate capacity of the pile? Ultimate load capacity, or we may require what is the safe capacity of pile. But how do we get? The load test, we only get load settlement behavior, okay, maybe of this nature. So I'm applying a certain load, 80 ton, 160, 240, 300. Now I may be getting these settlements of the pile. Now I may get something of this nature. Now, if I get this kind of a curve, what is the ultimate capacity? How do I find out the ultimate capacity? Or how do I find out the safe capacity is again a big challenge. If, for example, if I show you that, okay, load settlement curve is like this, then you can say that, okay, see, this is the peak point. After that, this is the maximum load the pile can carry. After that, there is a continuous settlement of the pile. But every time you may not get this kind of behavior, you may get this kind of behavior. What I showed you earlier, you may get this kind of behavior. If this is the kind of behavior you are getting, load versus settlement, what is the capacity of the pile? Capacity of the pile, I cannot know because pile keeps on taking the load. Now with the increased settlements, now I cannot say what is the maximum load the pile is carrying in this particular case. Okay, now we want what is the ultimate capacity and what is the safe capacity of the pile. Now again, go back to IS 2911. It says that the maximum load, ultimate pile capacity, is where the pile fails in shear or pile fails as a structural number. So this is either in shear or settlement. These are basically a geotechnical failures, and this is structural failure. The load at which the soil fails in shear or the load at which settlement is beyond the tolerable limit, that is ultimate load carrying capacity pile, or maybe the pile as a structural member fails in crushing kind of thing. Pile member fails, then this is structural failure. Again, load corresponding to this is the capacity of the pile. Now, if you see predominantly unbearing, as I mentioned, so there are two components of the pile capacity. So this is the pile and this is the ground surface, and you apply a load on the pile. This load is shared by the shaft resistance and unbearing. Now, predominantly unbearing, if more load is taken by, if it is predominantly unbearing, means most of the load is carried by the unbearing base of the pile, and this is very negligible. In that case, you can see here, this is the kind of load versus settlement behavior. Okay. In the case of frictional pile, where predominantly load is shared by the skin friction or shaft resistance, and unbearing is very, very minimal, then you can see here these kind of curves. Now, compared to this case, in this case, the finding out the capacity is very, very easy. You have a clearly, you can see where the maximum load is reached, and that is the capacity of the pile. In the case of the predominantly unbearing pile, so what we do, find out the unbearing capacity, or find out the pile capacity. We often use a 10% D criteria, wherein so the diameter of the pile is 1 meter. 10% of diameter is 100 millimeter. Now, corresponding to 100 millimeter, we see what is the load. That load we say that is the capacity of the pile. Now, IS code says two criteria for one criteria for less than or equal to 600 millimeter diameter pile. In this case, the safe capacity, please remember, this is safe capacity. Safe capacity is given as 2/3 of the final load at which total displacement attains the value of 12 millimeter. Okay. Now, what you need to do is take a load settlement curve And see, so this is the load settlement curve. Now see at 12 millimeter, whatever is the load, this load multiplied by 2/3. That may be the safe critical capacity. On the other hand, so again other criteria where 50% of final load at least total displacement equal to 10% pile diameter. Now again, once again, if I say that okay, diameter of the pile is 750 millimeter, 10% of the pile diameter is 75 millimeter. Now you draw corresponding to 75 millimeter diameter, you draw one more line and then find out what is the corresponding load. 50% of that load is safe criteria. So between the first criteria and second criteria, you need to take lesser of these two. Safe capacity of the pile. Similarly, for D greater than 600, so criteria is given here. So here is not 12 millimeter, but it is 5 millimeter. Okay, so again, we have IS 14593 and also piles. Again, these are the kind of settlement. But please remember the safe limits are given as 12 millimeter or 18 millimeter is safe. Means when you design a pile should not subject to settlement more than 12 millimeter, 18 millimeter. So if it is done, then the pile is not safe. Okay. There are some concerns with the current criteria. Current criteria, for example, if you see here, so we are saying less than or equal to 600 millimeter diameter or more than 600 millimeter settlement for estimating the safe capacity. However, the pile is very, very long. For example, you talk about 20-meter pile, 20-meter length pile and 1 meter dia. Now, 1 meter diameter pile and 20-meter length of the pile. Okay, the elastic shortening itself. For example, if you say, so what is elastic shortening? Approximately it is Q L by A. Elastic shortening is the elastic deformation of the pile. Now, for example, if I'm talking about something like a 20-meter length, 1 meter diameter pile, let us consider the load is 1000 ton. Now, if you see 1000 ton is nothing but 10,000 kilonewton multiplied by 20 meter by area of the pile by Young's modulus of the pile material. This itself is so high. Basically, by following these rules, capacity of the pile is underestimated. The long piles, capacity of the piles using these criteria is underestimated. Now you say that the capacity of the pile is only say 600 ton or say 800 ton. In reality, this may take more and more load. Now, if you look at the load settlement curve may be like this. Now you say this is the capacity. Now this is one of the issues for the whenever we use these criteria for estimating the safe capacity of the pile. And many times we use 10% pile diameter, but 10% pile diameter, so it will not relate to soil pile behavior or behavior of the structure. So, for example, if you see here 1 meter diameter pile, now 10% diameter is 100 millimeter. 100 millimeter is very, very high for a structure standing on the piles. Okay, so this 100 millimeter at the 100 millimeter deformation, at the pile settlement. So settlement of the pile may be of this nature. So you are talking about 100 millimeter here. So wherein the pile already attained maximum capacity. And again, many times as I mentioned, so it is if you don't go with the provisions, IS model provisions to find out the safe load, then we have many time-tested methods are there to find out what is the capacity of the pile from the known the load settlement data. You can follow Davis and offset limit methods. What it says now, if you see here, if this is the load settlement curve, this is the load settlement curves. What it says now, you draw the elastic settlement response. This is elastic settlement response. Now then there is offset method. This is offset methods. There is offset here. This offset, if you look at this offset is nothing but 1.5 inch plus D by 120. Again, D by 120, D in inches plus the elastic shortening. If you talk about PL by AE or PL by AE. Now, if you draw this line, so this is the elastic shortening line, and this is the deviation criteria. Now, this point here, this line, wherever it meets the load settlement curve, that is this point, the load here corresponds to this load, corresponds to ultimate load. Now, these are some of the criteria which many books or many researchers use to obtain what is the ultimate capacity of the pile. Now, again, you can see here, this is the elastic line, and this is 0.15 inch plus D by 120. This is the offset. Now, this point where the load settlement curve meets this offset, that is the QF, nothing but ultimate. Like this, there are criteria available, and please remember here what we noted that the static load test, especially when you're talking about very, very high loads, if you want to test the pile to 100 ton or maybe 1,000 ton or maybe 2,000 ton or more than that, now you need to build a very, very heavy platform which is 25% more than the load to be tested. Okay, so either by cantilever system or by anchor piles or ground anchors. Now, the construction of this platform itself takes enormous amount of time. Now, instead of that, what we can always do is use the technology. Now, technology is available now. Okay, so if you use a technology, now this effort can be completely eliminated. Now, how do we do that? One of the upcoming used recently developed method is a bidirectional pile load test. Now, as I discussed, now if this is the pile to be tested, this is the ground surface. Now, you need not have any kind of reaction, either by cantilage or reaction by nothing is required here. Instead, what you do here is you provide, these are basically a load cell, what we call. Provide a load cells here, and then like your hydraulic jars. Now what we need to do is we need to pressurize them from the ground. Now what happens once they are pressurized, the volume of this cell increases. The volume of the cell increases, then what happens? Because there is a pile segment above this cell and pile segment below this cell. Now, as you keep on increasing the pressure or load, now there is a movement of the pile in this direction. Top portion of the pile and bottom portion of the pile moves in this direction. At one point of time, so now once if you see here, so instead of one curve, what you get is you get two curves here for the upper portion and maybe for the downward portion. This is say here is the load. And this is settlement of the upward portion here and settlement of the downward portion of the pile here. Advantage. Now, all this can be completely avoided. All these heavy reactions and time taken process can be completely eliminated. Okay, so when we are using a bidirectional load test. Now, that way what happens, even space, there is so much of space around the pile to be tested, so is required here, but that is all not required in the case of bidirectional pile load test. Now, in some cases, if you don't construct your control system properly, then there is a possibility of failure or hitting of the cartridge, and these pose serious threats to the safety of the people And of course, it also causes a lot of loss of resources and time. Now, to avoid this, we can always go for the bidirectional load testing. And not only that, even for example, this is a part of Mumbai Trans Harbour project. Majority portion of this project is basically a bridge connecting two islands, two parts of Mumbai. And now what happens? Majority portion of this bridge is going into the sea. Now in the sea, this is a pile visible. Now, how do you test this pile using the conventional reaction loading system? Because you cannot construct a reaction yet, it is very, very difficult for us to do that. Instead of that, if you go for bidirectional load testing, so you can quickly find out what is the capacity of the pile and accordingly so design the pile and the superstructure in very, very limited time. Now, as I mentioned here, this is a jar. Yeah, nothing is there, only very, very simple things are placed at the ground surface. No, basically these internal reactions. Now, for the top portion of the pile, bottom portion acts as a reaction. For the bottom portion of the pile, top portion acts as a reaction. Okay, so no external reaction is required here. And ultimate capacity, of course, there are limitations also. We'll discuss that part. And when it is when this is jack is pressurized, top portion moves upward, bottom portion moves portion. Advantage is very safe, and it is time safe. Now you can see here, this is a cell which is placed inside the pile. Of course, Fosterberg is one of the inventors of this cell. And in the market today, there are many other companies also operating. They have their own cells. Now you can see either it is a one cell, or maybe you can see depending on the diameter of the pile and capacity of the pile, multiple cells can also be used. Now this cell is placed in the pile along with the reinforcement cage. During the reinforcement cage, when we lower down the reinforcement cage, to the reinforcement cage, this cell is placed. Is properly fixed to the reinforcement cage by a top plate and bottom plate. And there are some, you can see here, a bottom plate and top plate have holes. So that once the reinforcement cage is placed, concreting can be done. The bottom portion without any interruption. Now, you can see here there are some transducers, nothing but displacement transducers are attached to the bottom plate and top plate also. Once we start pressurizing this is hydraulic control. You can see here. From this it is operated. Once it is pressurized, now top plate moves upward in the top direction, bottom plate moves in the down. Now you can measure the displacement. You know how much pressure you are applying at each stage. Knowing the displacement of the top plate and bottom plate, you can get what is the top plate load settlement curve and bottom plate load settlement curves. Now, if I compare the conventional load testing and bidirectional load testing, now in the conventional load testing, load is applied on the pile top and pile the downward direction. But in the bidirectional, because the cell is placed at some depth below the pile head, pile moves in both directions. Above the pile segment above the cell moves in the upward direction, pile segment below the cell moves in the downward direction. And in the conventional system, you want 25% more than the maximum load as a reaction required, but here there is no reaction required. As I mentioned, top portion of the pile acts as a reaction to the bottom portion acts as a reaction to the top portion. Of course, here you can always test the pile to the ultimate capacities. However, in the bidirectional load testing, what exactly happens if once one of the portions of the pile, either top portion above the cell or bottom portion below the cell, if they attain the maximum capacity, then so no further loading can be obtained. That is the reason maximum loads cannot be obtained. You will not be, most of the cases, you will not be in a position to find out what is the maximum failure load of the pile in the case of bidirectional load testing. It is very, very quick. And duration is also a quick testing. And when it comes to the interpretation, of course, the conventional load testing is time tested. For decades, we are using the conventional pile load test. This is very, very relatively new. And interpretation of the results is a little involved compared to the conventional load test. And selection of pile for load test, the conventional piles, once all piles are inserted also, that time also you can always select, okay, I want to test this pile. In the case of bidirectional load testing, because the load cell should be placed along with the reinforcement cage, you need to select the pile beforehand. You cannot, after piles are constructed, you cannot do this test, because this test requires that load cell should be installed pile itself. That is the reason they are selected at the start itself. And any load can be applied up to the maximum reaction, but here it is unlimited. Okay, so because there is no external reaction here, so unless one of the portions of the pile is pile reaches its maximum capacity, otherwise there is no problem. And test the pile to any loads in the case of bidirectional load testing. Okay, so now I don't want to tell you much on this. There is, as literature is available, maybe you can see ASTM 8169 to understand more on bidirectional load testing. And as I mentioned here, so even you can connect a digital displacement transducer to measure what is the upward settlement of the pile head. Okay, all those things can be. Yeah, you can see not only somewhere here, but even at the bottom also, anywhere you can always put your load cell. The bottom, very close to the bottom, is provided when you are designing piles as rock solid. When you notice that the rock here, pile is resting on rock, which has very, very high capacity, then you can choose the location of the cell very close to the pile bottom. Various instruments, this is a lot of electronic instruments are required to be used in this bidirectional load testing. There are single or multiple load cells are required, and then telltales. Telltales basically is to monitor the top plate settlement. How do you monitor the top plate settlement? Now let us consider this is the pile, ground surface here. Now load cell is placed here. Now there is a top plate and there is a bottom plate connected to the load cell. How do you measure the top plate movement? Now what we do is we put a telltale. Hollow pipe is connected to the bottom plate and top plate, and then a rod is placed. A rod is connected to the top plate. A rod is connected to the bottom plate, and this rod is freely moving within that hollow pipe. And if the plate settles or if the plate is moved up, then the rod connected to the plate, this rod connected to the plate, what we call as a telltale, is also moves. So by noting down the movement of the rod connected to the bottom plate and top plate, you can understand how much movement the top plate undergoes and how much movement the bottom plate undergoes under given pressure. And then displacement transducers to find out if you want the top settlement of the pile. Okay, you can always do. And using the telltale also, you require some displacement gauges which are connected to telltale to measure what is the movement. Even pressure gauge is required pressure complement is required. Pressure gauge, again, same thing. Pressure gauge is to monitor how much pressure you are applying. That is read from the pressure gauge. This is another view we can see here. A multiple cells are placed here. This is bottom plate and this is the top plate. These are the openings provided in the bottom plate and top plate for concreting, and also to carry certain instrument wires of the instruments. Now, once the load test is conducted, you can see this kind of behavior. Now you can see this will be for the for shaft is nothing but the top portion. Top portion displacement versus load. When you apply a certain load, 300 kilonewton load you applied on the you gave to the cell, under 300 kilonewton load, what is the movement of the top plate upward, and under the same load, what is the movement of the bottom plate downward? That is the this is the location of the cell here, and these are the various strain gauges. Location of the strain gauges. Through strain gauges, you can find out what is the load transfer at various elevations. And this is the pile head. There is no movement of the pile head. Okay, and you can see here. So this much load is applied. You can see here. This much load is applied at the cell level, load cell. And when it reaches this depth, this much load is already shared by the soil in the load cell and the strain gauge. Like this, you can see. Okay. Ultimately, what we require is not the independent load settlement curves for the top portion, bottom portion. We want the top down, basically. From these two, we need to generate a load, a single load, top load settlement curve we need to generate. Similar to what we see the conventional pile load testing. You can see here so various details, and then this is another this is a whole cell, one type of a cell here by bidirectional testing. These are the other types which are recently used in one of the projects in near Rajkot. Technical name is CHARUSAT. This is a whole cell and this is CHARUSAT. There are many details that are required to be understood for this particular testing. I'll give you this data to you for your future reading. Okay, I'm not discussing much on this, but just I'm giving you an overview of how the load settlement response you get when you conduct bidirectional load test. Okay, so several observations, and quickly I threw some light on high strain dynamic load testing. As I mentioned here, pile load test can be conducted using high strain dynamic load test to get its capacity. In this case, a heavy hammer is dropped continuously on the pile head, and you can see here. So, in fact, force is given by driving hammer, and it is dropping from a certain height. And then what happens here is we measure basically what we do is we this is the pile. Now this is, let us consider this is the ground surface, and we install some accelerometers and strain gauges, and these measure the force. Now, under every impact of the hammer, you can find out what is the force measured near to the pile head and what is the displacement of the pile under the given impact. Now, from there, you can find out how good is the system, okay, how good is the pile system, and then so you can also find out what is the capacity of the pile from this. Okay, you can clearly see here what is happening. This is a pile. Now to the pile, you can see here these are the gauges connected. One is accelerometer, another one is strain gauge connected here. And they are basically two are connected diametrically opposite. Whatever is done here exactly on the diametrically opposite, you have this is one, this is another one, and similarly now you put one here, then you need to have one more here. So diametrically opposite you provide. And then what happens here? There is a cushion placed on the pile head to protect the pile head from damage, and the hammer is falling from this side to this side. And then the force and velocity under each hammer blow, force and velocity records are recorded or monitored. And from there is a signal processing, signal matching software, what is called PDA, Pile Dynamic Analyzer. So using that, you can always get what is required is the pile resistance. A pile capacity is obtained once you know what is the force and velocity. So now from the strain gauges, we get strain, stress, and force. From accelerometer, we get velocity and displacement. Once you know what is the velocity and the force, you can always get what is the pile resistance. The very quick test you can always do and get the required results. Now, of course, you can see this. Okay, there is a link here. You can always go through that link and maybe. Maybe you can see here the pile to be tested here. And this is a arrangement for hammer. Okay, now you can see here. Yeah, these are the instruments, as I mentioned, accelerometers and strain gauges are connected to the pile. And then under each hammer blow, we get what is the, you can see here. So this is how the blows are given to pile. Depending on the height, you can clearly see what is the velocity and force. And from there, you can find out using the signal matching software, you can find out what is the capacity of the pile. So quick compared to the conventional reaction loading, static loading. Yeah, you can see here. Okay, so this is yes. Okay, so of course there is a lot to discuss on this, but you can see one important thing here. Whatever capacity we get from the dynamic testing, this is called high strain dynamic load test. And this you can see to find out the capacity of the pile, use a factor of safety of 2.25. But if you get the capacity from the static load test, then you use a factor of safety of 2. Okay, so this is the end of my presentation. And if I summarize what you learned in this is, we noted the conventional load test, various aspects of the conventional load test, right from the Cantrell system, reaction loading system, and we're seeing the advantage of load cell here, what we measure in the load test, and how once the load settlement data is obtained from the conventional load test, how to find out the ultimate capacity and safe capacity. Throttle provisions we understood. And then we've seen the bidirectional load testing, and we noted the advantage of bidirectional load testing compared to the conventional load testing. And then we toward the end we've seen the high strength dynamic load testing to get the capacity of the pile. Okay, and let's keep learning, and that way we can always enhance our knowledge. Knowledge is infinite, and the moment we stop learning, I think that is the end of the day. These are the important references. And thank you very much. If you have any questions, I can take up. Otherwise, you can always write to me.
Yes, sir. The session was very informative, sir. Sir, we are having some participants.
Yeah.
Srinivas, sir, you can.
Good afternoon, Dr. Murthy. Excellent presentation. I did learn a lot of important points, and my specific question is regarding the telltales. You were talking about O cells. O cells. In the presentation, like these O cells are like they are part of the file, and they are like install and forget.
Yes, they are sacrificial.
Sacrificial.
Okay. Once you do any test, it is over. So advantage is you can also use them in your routine file also.
Okay. So they can be monitored to the entire lifetime of the file of the structure, I guess.
But the only issue is once you finish the test, and if it is a routine file or file which is part of the foundation system, then you need to put your concrete. After that, you need to fill those gaps formed by the piston of the load cell, or the openings made by the load cell, expansion of the load cell. That whatever gaps created should be filled with the concrete. So that way, once it is completely done, you cannot do anything.
That is what, in fact, you very nicely mentioned. Yes, if it is a test file, it's okay, but if it's a working file, it's a challenge.
Yeah, working file, it is a challenge. Of course, technology is available now to seal all those openings formed by the expansion of the jack.
But I still am worried about, if it's a working file for test, but then it's for a test file, isn't it? Not for a working file, right? The O cell is installed for a
it is also used for routine file also.
But then my worry is, how is the gap filled up? Once the job of the O cell is over, done. So how do I fill up the gap left by the O cell?
No. That is the reason I told there are openings made on the top plate and bottom plate through which our concrete. Basically, if you see the you have pipes for telltales, right?
Okay.
They are basically hollow pipes. Now through these hollow pipes, you can always inject your grout or whatever, and see that.
So, but then the O cell will be still there, right? It can't be.
Still, it is there. It is sacrificial. It will be there forever.
So that the presence of O cell would not cause any subsequent to grouting.
Nothing. That is what
will not cause any strength loss.
Yes, nothing.
Oh, that is
only thing is we should be worried that because the expansion whatever taken place, that once we start constructing our superstructure, that should not collapse.
Yeah, that is also what I was thinking actually.
Yeah. No, but people have been using that. People have been using that. Technology is available. People are doing it, completely filling that gap.
It's successful.
Yeah, it is successful.
What is the size, sir, of the O cell and the cost?
Sir, presently it is, I'll tell you, the Rajkot, one of the tests conducted, so which I was part of that, and around, I think 500, 600 ton load or so, but of course they conducted up to 1000 ton or so. Okay. Not very high, I think around 10 to 12 lakhs is each test.
Okay, that sacrificial one will be costing 12 lakhs.
Yeah, total the contractor charges 10 to 12 lakhs.
But the cost of the cell I'm talking about, cell.
Because see, sir, they are not openly available in market. So they are, I should say, they are proprietary item of the contractor.
Okay, but then how big or how small it is?
No, anything. I told so. If it is single pile, small pile, or large pile, whether single one cell or multiple cells, they can always use. It is basically because it is a proprietary item.
Okay.
Depending on the user's requirement, they manufacture the cells.
Okay. Okay. But is there any codal provision that this many files should be installed with OCell and monitored?
No, actually, presently we don't have only a class says that the OCell can be used, but nothing
be.
like OCell
not
should
should
be
be.
used kind of thing.
Okay. Okay.
Yeah, there is no mandatory requirement that OCell, and on the other hand, we have a mandatory requirement that conventional test should be conducted.
That's correct. Correct.
Yeah.
Thank you.
So,
Very,
yeah.
very nicely. Thank you so
sir.
much.
Thank you, sir. Thank you.
Good afternoon, sir.
Yeah, tell me.
I am Pratiti Bhatt from Vidyanagar,
Okay.
and you told regarding Supercell.
Hmm.
Yeah, I am working in the Supercell.
Oh, very good. Okay.
Yeah.
Yeah.
So I am very happy to see my data.
Yeah. Right.
Yeah.
Okay.
I have one question for that.
Yeah.
If the sensors are provided in the bidirectional,
Which sensors you're talking about?
like the concrete temperature regarding and the some parameters like strength.
Now technology is available in the market. Only thing is because they are still a proprietary items, one should talk to the supplier and see what kind of sensors we want, and they are ready to do that also. I think in this, you know better than me. So
I know, sir. But I think the latest market is maybe sensors are provided, but it is for the only temperature regarding the temperature, not the more than. I provide the supercell strain gauge also, but it is for the strain gauge displacement, etc. Right? So I think we provide the sensors in the pile foundation.
Yeah.
So we know the structure behavior of the in future after 10 to 15 years ago.
Yeah, right.
So,
This is similar to whatever we do for the structure, the foundation monitoring in the conventional piles also. Not as part of the supercell. Supercell will not be useful once the test is over.
Yeah.
But you can always attach these kind of sensors on the reinforcement cage of the pile.
Yeah.
And they give you the load transfers with the time.
Yes.
There will not be an issue.
Okay.
Hello, sir.
Yeah, tell me.
Thank you, sir.
Yeah, thank you.
Thank you for wonderful session. And sir, I have one question.
Yeah.
Sir, after casting the when we should perform the test after casting the pile? When we should perform this bilateral test?
You are saying pile integrity? Pile integrity?
Yes, pile integrity test. Yes.
Sir, anyway, please see that the pile should be set. The material should be set. Now, if the required strength is not there, then your signal will be poor. Sir, if it is not set properly, because your signal is basically integrity test or high strain dynamic load test. If you see, the signal propagation is a function of material properties. I should say the density of the material, modulus of the material. Now, if it is not properly set, then so your signal will be poor. You may, if you don't understand properly, you may feel that the pile is of inferior quality. That is the reason code always says that at least a week after casting should be allowed, and also to see that the proper, at least double the strength of the allowable stress should be achieved before we conduct these kind of tests.
Okay, sir. And one more question, sir. At what if we should place this OCell during bilateral load test?
Lateral load test, no, sir. Lateral load test is not.
I mean, bidirectional load test. At what depth we should place our OCell?
No. Again, please remember, there is no external reaction, right? If you provide very close to, let us say, 1 meter, if pile length is 10 meter, you provide, let us consider that you provide at 1 meter below the pile head. Right, sir? Now, when you expand, when you stress the cell, pressurize the cell, now top portion, if you look at, there is only 1 meter length of the pile which resists the force you are imposing. Right, sir? Now, what happens? Hardly within no time, your top portion will be subjected to maximum pressure, and once that is done, your bottom portion will not get any reaction. any more reaction. So that is the reason this is basically called a balance point. Again, it is not a straightforward. We need to see where your top reaction and bottom reaction. The shaft resistance of the top portion equal to shaft reaction of the bottom portion plus end bearing of the pile. Where they are equal, that is the best point. That is what we call as a balance point where we need to put our cell.
Okay.
Otherwise,
Okay.
what happened? Otherwise, your test will fail very early.
Okay, sir. Okay, got it. Thank you, sir.
Good afternoon, sir.
Yeah,
I have
okay.
one basic question.
Yeah,
So
tell me.
generally, in laboratory, we always do strain control tests, sir, like direct shear test. But
Yes.
the pile load test or plate load test, if you see, as you mentioned rightly in the slide, we always perform in stress control testing, like maintain load test.
Yes.
Is it why it is difficult to do constant penetration test? Is it due to stagnation of soil air? We can't maintain.
Sir, it is very, very
2
difficult.
mm.
You tell me, if I ask you to maintain the displacement constant, maybe 1 millimeter per minute, sir, it is not so easy with whatever conventional tools we have. In the laboratory, yes. In the laboratory, you have the automatic systems available now. Either you can simply, like your triaxial testing, you tell me what is the triaxial testing, what loading we use. Triaxial testing, you use a displacement controller, 1.2 millimeter per minute.
Correct, sir.
Because there is automated system, but manually, if you want to apply, it is very, very difficult.
Strain control.
Displacement control. Please remember the stress control, displacement control, and strain control. Both are, all these three are different. Strain control and displacement control are also not one and the same. Displacement control, where you only monitor or you only control the displacement, not the strain. Strain has a different meaning.
Correct.
So only because you cannot, with the conventional tools available, Rakesh, with the conventional tools available, we cannot perform a strain control or displacement control in the site. It is very, very laborious, and we may do many mistakes in doing that.
So normally, when we compute the static with that pile load capacity using static formula from the bore log data, most of the time that may not match with the real field test, maintain load test. So
Yeah.
if I have 5 or 6
Sir, no, tell me.
Can I do back calculation and calculate the parameters and I?
No, you tell me when they are not matching. When they are not matching, which one you question? Whether you question your analytical procedures or you question your testing procedure.
Because testing procedures are more reliable, sir, we'll get.
That is the reason. Basically, what we do is because when we are using some kind of methods to find out the capacity using the IS code method or some other method, they have their own limitations. You use certain value of a friction angle cohesion, you don't know whether that is true or not. Right, sir? So not only that, even if you look at the stress control method, this stress control method simulates the real loading. In the real loading, once the pile is constructed, now tell me how we load the pile. We construct first story, second story, third story, basically loading the pile in increments, stress increments. Okay, we are not loading the pile in the displacement mode or strain. Even if you look at the simulation of the real loading on the pile.
Thanks.
Thank you, sir. Any more questions from participants? Okay, so with this, we will wrap up the session over here. Thank you, Murthy sir. The session was very informative, and we also had the great sessions with the Q&A session also, and it was very informative regarding the deep foundation, where sir has discussed the various different types of pile load test, as well as the various concepts or the field issues which we are facing during the test, and the various concepts and the what we can say, the IS provisional codings with us. So it was very informative session for us from your side, sir. Thank you very much.
Thank you, ma'am. Thank you.
Thank you.
Okay, so have a nice day, and I hope all the participants will enjoy the entire program. And let's see that you learn something from these kind of courses, because bringing people is really a very tough for the organizers. Okay, so as long as you are learning, we'll be very happy to be part of these kind of programs. Thank you very much.
Thank you, sir. Thank you. I request all the participants, we will take up a small break of 10 minutes and we will start our next session at 2:45. That will be conducted by Dr. Abhishek Kumar from IIT Guwahati. So be with us. The meeting will be the session will start after 10 minutes. So we will just take up a break of 10 minutes and we will write back after 10 minutes.